Welcome to ThirdEye Labs, where we make the unseen seen. Before we touch any artificial intelligence, we have to meet the most fundamental object in all of mathematics, the function. Master this one idea, and everything that follows will make sense. Picture a vending machine. You press a button, that is the input, and out comes a snack, the output. A function works exactly the same way. It is a machine that takes something in, follows a fixed rule, and gives something back. Feed in the number 3. The machine processes it and returns a single, predictable answer. Hold on to this picture, because here is the punchline for the whole series. A neural network, the thing behind modern AI, is really just one enormous function. Training it simply means reshaping that machine until it gives the outputs we want. We write a function like this. The letter f is just its name. The x inside the brackets is the input, and the part on the right, 2x plus 1, is the rule it applies. This often trips people up. F of x does not mean f times x. The brackets do not mean multiply, they mean f applied to x. It is the machine acting on its input, nothing more. So how do we see a function? We draw its portrait, called a graph. The horizontal axis is every possible input x. The vertical axis is the output, f of x. Watch. For each input, the machine gives one height. As we sweep the input from left to right, the yellow marker plots that height and traces out the curve. The graph is just every input-output pair drawn at once. A function has one unbreakable rule. Each input gives exactly one output. Same button, same snack every single time, so what breaks the rule? Look at this curve. We drop a vertical line at one input. If it ever crosses the curve more than once, that single input is trying to give two different outputs at the same time. That is not allowed. This quick check is called the vertical line test. Not every machine accepts every input. Take the square root function. You cannot take the square root of a negative number and get a real answer. So its allowed inputs, called the domain, are the numbers from 0 upward, and the set of values it can actually output is called the range. Domain is what is allowed in. Range is what can come out. Keeping these straight will matter the moment we feed data into a model. 3 shapes will follow you through all of machine learning. The linear function, a straight line, the simplest possible rule. The quadratic, a gentle curving bowl which shows up in error measures. And the exponential, explosive growth, which powers probabilities and loss functions. Here is the idea that makes machine learning possible. Most functions have dials, called parameters. Take the straight line, f of x equals a x plus b. The number controls the slope, and b shifts it up or down. Watch what happens as we turn the dials. The very same machine becomes a whole family of different lines. This is exactly what training an AI does. A neural network has millions of these dials, and learning simply means turning them, little by little, until the function fits the data. Remember the machine metaphor. Training is just tuning the machine. If a machine takes you from input to output, can we run it in reverse? Often, yes. The reverse machine is called the inverse, written f with a little -1. If f doubles a number, its inverse simply halves it. Double 3 to get 6, halve 6 to get back to 3. The inverse undoes the work. This idea quietly powers encryption, data compression, and the generative models that turn noise into images. So far our machines took one number in, but nothing stops a function from taking many inputs at once. We can write f of x1, x2, x3, and beyond. A house price might be a function of its size, its location, and its age. 3 inputs, 1 output. Now imagine not 3 inputs, but the 784 pixels of an image, or thousands of words in a sentence. That giant, many-input machine is exactly what a neural network is. Everything in this series is just functions, growing more inputs and more dials. Here is the idea that quietly runs every deep network. We can feed the output of one machine straight into another. Let G add 1, and let F double its input. Let us push the number 3 through. First G turns 3 into 4. That 4 flows into F, which doubles it to 8. So f of G of 3 equals 8. We just composed 2 functions into one bigger machine. Stack thousands of these machines, and you have a neural network. And when we later ask how to train it, we will need to unwind exactly this chain. That unwinding has a name, the chain rule. But that is a story for a future episode. Let us recap. A function is a machine that turns an input into an output by a fixed rule, and each input gives exactly one output. A graph is its portrait, and its parameters are dials we can tune. An inverse runs the machine backward. And when you give a function many inputs and many dials, you get the giant machines we call neural networks. That is the thread running through this entire series. Thanks for watching and keep exploring. Next time, we will decode the scary symbols, sigma, pi, and nabla, so no equation ever intimidates you again. Please like and subscribe ThirdEye Labs if you enjoyed this video, and let me know in the comments.